In the PreTrig review part 15, we go over how to work with lines and rays. In example A, we're asked to graph 4x minus 3y is equal to 0. One of the easiest ways to graph is to get a line into slope-intercept form, so we need to solve for the y. So we will subtract 4x from both sides. And now we have negative 3y is equal to negative 4x. I'm going to divide both sides by negative 3. And now we have that y is equal to 4/3 x. So we know that our slope is equal to 4/3 and our y-intercept is equal to 0, 0. Pretty easy to plot a couple points in here now. So we know we can make a little grid even. We've already said we have 0, 0. We know we have that point. And we want to pick another point that's easy to graph. And since we have a denominator of 3 here, we might as well pick that x is equal to 3, so that the 3 in the denominator cancels with the 3 that we're putting in for x, and we find out that our y value is 4. So we can plot the point 0, 0 and 3, 4, and there's our line. And you should also notice that we could have used the slope to graph this line. Starting from our y-intercept of 0, 0, we notice that the slope says to go up by 4 and over by 3. So starting from here, if we went up 4, 1, 2, 3, 4, and over by 3, 1, 2, 3, we land on the next point on the line. In example B, we have 2x plus 5y minus 10 is equal to 0. So again, we're going to get this line into slope-intercept form, which means solving for y. So we can first subtract 2x from both sides, and at the same time, let's go ahead and add 10 to both sides. So now we have 5y is equal to negative 2x plus 10. We're going to divide both sides by 5. And now we have y is equal to negative 2/5 x plus 2. We know that our slope is negative 2/5, and our y-intercept is 0, 2. So we can use those two facts to go ahead and graph our line. If we start at our y-intercept of 0, 2, and then we use our slope, since it's negative, we know that means we have to go down by 2 and to the right by 5. And that would be our second point. So our second point we can see is at 5, 0. In example C, we have something a little different because you notice in addition to the equation of the line, we have this restriction on the domain that x has to be greater than or equal to 0. Now what that does is turn the line into a ray. So let's see how that happens. As before, we're going to solve the equation for the line for y. So we're going to subtract 3x from both sides. And now we have 5y is equal to negative 3x. Divide by 5 on both sides. And we have that y is equal to negative 3/5 x. Now we can use the y-intercept and the slope to make the graph, or we can pick 2 points to make the graph. Either way is good. We just have to remember that any points we use for x have to be greater than or equal to 0. So, for example, we know that we have the point 0, 0 on the graph. That's easy to see. And to pick an x value, again, we use our denominator as 5, so we're going to go ahead and pick that x is positive 5 because that is a positive x value. So if we pick that x is 5, then y is going to be negative 3, and we can go ahead and plot those 2 points to get the graph of our ray. So we have 0, 0, and we have 5, negative 3 right here, and our ray is heading off in this one direction only. In example D, once again, we can see we've got the equation of a line followed by a restriction on the domain, which turns that line into a ray. So let's solve for y. This time we'll add 4x to both sides. And now we have 3y is equal to 4x. So we're going to divide by 3 on both sides. And now we have y is equal to 4/3 x. We plot a couple points, pick our favorite point, which is x is 0. If we plug that in, we see y is 0. We can go ahead and plot that point. And now we're going to pick an x value that's convenient. We see our denominator is 3, so we want to pick a multiple of 3, 3 or 6 or 9, just to keep our life easy. But we have to pick x values that are negative. So we can't pick positive 3 this time. We're going to have to pick negative 3. If we put negative 3 in for x, that will cancel with the 3. We're left with a negative 1 times 4, which is negative 4. So to plot our ray this time, we're going to go negative 3 and down 4. And here's our ray. So when you have the equation of a line followed by the restriction on the domain, it takes the line and turns it into a ray. Now in example E, you're just being asked to look at the graph and estimate the slope of each line, and then state if that is steep or shallow. So in this first one here, remember, you're just estimating. So if it appears like you're going up maybe 3 and over 1, you would say that your slope is approximately 3 over 1, which is 3. And that is considered to be a fairly steep slope. In this next example right here, you would use the same technique. Say if I start here and I want to end up on the line, it looks like I go up 1 and maybe over 2, so my slope appears to be about 1/2, and that is considered shallow. When it's beneath 1, we tend to say it's shallow, and when it's bigger than 1, we say it's steeper. When we look at this line over here, pick any point on the line, and then go down and over to land on the line again, and it appears that we have to go down by about 1 and over to the right by maybe 4 or 5. So we would say that this slope is approximately negative 1/4, and that is a shallow slope. But notice that it's negative because the line is decreasing as I go from left to right. In this last example here, if I start on a point on the line, I have to go down and over to land on the line again. And it looks like maybe we go down a little farther than we go to the right. So in this case, I might estimate my slope to be down by 2, to the right by 1. So maybe my slope is about -2. And we would consider that to be steep.